Hello to all dear students. In this video, we will be discussing about another topic of biostatistics, that is frequency distribution, cumulative frequency distribution, and lastly stem and leaf plot. So starting with frequency distribution. It is a table showing different values of the variable and their respective frequencies side by side is called as frequency distribution. Frequency distribution is a statistical table which shows the set of all distinct values of the variables arranged in order of magnitude, either individually or in groups with their corresponding frequencies side by side. Like for example, we have got classroom and we want to know how many girls and boys are sitting in this classroom. So if we start counting it, that at the first place there is a girl, next to girl there is another girl, next we have got a boy, and then in the last place we have got a boy, beside him one more boy, and lastly there is a girl. So you can say this is a kind of raw data, and we want to build a frequency distribution of this raw data. So we can write it in this manner. Variables, we have got two variables, boys and girls, and these are the frequency. We have got 3 boys and 3 girls. So basically this is known as frequency distributions, where the variables, the frequency of the variables are being written side by side. Next, a frequency distribution is the organization of raw data in table form using classes and frequencies. Here we have got 3 types of frequency distribution, that is categorical frequency distribution, ungrouped frequency distribution, and lastly grouped frequency distribution. Here this is an example of categorical frequency distribution. We have got 2 categories, boys and girls. These are the 2 categories. Next, we checked blood group of 500 kids. Okay, so 250 kids had got blood group O positive, 3 kids have got O negative blood group, 98 kids had A positive blood group, 0 had A negative blood group, 73 had B positive, 23 had B negative, and 3 kids had AB positive blood group. So this is also a kind of frequency distribution. Here the blood group is nothing but our variable, and these all are the frequency. And this is also an example of categorical frequency distribution. Next, suppose you are playing with a dice and you threw the dice 10 times. So what all might be the frequency, or what all might be the possibilities? First of all, the first term you had 3, next you had 5, next 6, 2, 4, 2, 5, 1, 1 and 5. So these all are the variables, you can say. Okay, so variables, we have got 6 variables, obviously, because a dice have got 6 as the maximum limit. 1, 2, 3, 4, 5 and 6, these all are the variables. Next we shall check out the frequency, like how many times we had 1, that is 2 times. So we can write here 2 is the frequency of coming 1. Next, what is the variability, or what is the frequency of 2? Here we can see 1 and 2. 2 times we had 2. Next, what is the frequency of getting 3? Yes, just 1 times. For 4, just 1 times. For 5, 1, 2, 3. So 3 times we got 5, and lastly 6 we had just 1. And this is an example of ungrouped frequency distribution. Okay, this is not a kind of category, this is a numerical variable, and this is an example of ungrouped frequency distribution. Next, here is another example. Here you can see an example of group frequency distribution. Now see, basically here you can see a table that shows serum cholesterol changes resulting from the administration of a cholesterol lowering agent to a group of 156 patients. The data are presented in order in which results were reported from the clinic. So basically this is a raw data where we cannot judge anything regarding the drug. Now this table, it shows a deviation frequency or number of occurrence of the values that fall into various class interval of the serum cholesterol changes. Clearly, the condensation of the data as shown in frequency distribution in this table, it allows for a better feeling of the experiment results that do the raw data represented by the individual 156 patients. For example, one can readily see that most of the patients had a lower cholesterol level in response to the drug, that is a negative change, and that most of the patient lies between 160 to plus 19, isn't it? Now, this is an example of grouped frequency distribution where we are grouping, where ranges are present. Now, for these ranges, what you can see over here, this is known as the upper class limit and this one is known as the lower class limit. Now, what are all the class? The class means these numbers 1, 2, 3, 4, 5, 6, 7 and 8. So, these are classes. So we can say there are 8 classes. See, when constructing a frequency distribution, two problems must be addressed. The first problem is how many classes or intervals should be constructed, and second problem is the specification of the width of each interval, that is specifying the upper and lower limit of each interval. Anyways, there is no definitive answer of these questions. The choices depends on the nature of the data and good judgment. Now, and another way to construct the interval is to have boundary values. Boundary value means there is a significant figure than the actual measurement, so that none of the values can fall on the boundaries, and that extra figure is conveniently chosen as 0.5. Like in the first class you can say 100 to 81, so we have got minus 100 to minus 81, so we can have a boundary of minus 100.5 to minus 80.5. Okay, so these are the boundaries, so that none of the figures should be escaped or eliminated. So this is about the frequency distribution. Next we shall talk about the cumulative frequency distribution. A large set of data can be conveniently displayed using a cumulative frequency table or plot. Like for example, a marks of 0 to 10, 10 to 20, 20 to 30 and 30 to 40. Okay, alright, this is an example of grouped frequency distribution, right? Next we have got a frequency of 4, 7, 2 and 9. Means 4 students got marks between 0 to 10, 7 students got marks between 10 to 20, 2 students got marks between 20 to 30 and 9 students got marks between 30 to 40. And if we add all these frequency, we will get number 22. That means total 22 students wrote this exam and these all are the marks in ranges. Next, cumulative frequency means we should add all. Like 0 to 10 we had 4 students who got marks 0 to 10. Next, in cumulative frequency we should go on adding everything. Like 4 plus 7 will have 11, 11 plus 2 13 and 13 plus 9 22. So the last number should be in total all the students, that is 22. Next, if we use the upper limit, okay, in that range, in that class, if we use an upper limit of marks, that is 0, 10, 20, 30, like in cumulative frequency, upper limit marks means 0, means how many students scored more than 0. Obviously all the 22 students scored more than 0. Next, upper limit of 10 means how many students scored more than 10. Okay, so 22 minus 4, because 4 students scored between 0 to 10, so we should minus or subtract 4 from 22, so we will get a value of 18. Similarly, upper limit of 20 means how many students scored marks more than 20. The answer is 11. And lastly, how many students scored marks more than 30? We will get 9. So this is the cumulative frequency all with upper limit. Similarly, we can also make a cumulative frequency for lower limit. Lower limit means marks is 10. So how many students scored marks less than 10? So we'll have 4. Next, how many students scored marks less than 20? We'll have 11. See, in this first we knew that 10 to 20 is scored by 7 students, but we want a lower limit, means how many students scored marks less than 20. So it will also include students who scored marks between 0 to 10. So 4 plus 7 we got 11. Similarly, how many students scored marks less than 30? We got 13. And lastly, how many students scored marks less than 40? Obviously the entire class, that is 22 students. And basically in cumulative frequency we are using this lower limit only. Next, I hope you understood this example, and now we'll have a pharmaceutical example now. Here you can see Like for example, here we have a data for frequency distribution of tablet potencies. Like a tablet having a potency between 89.5 to 90.5, we have got just one tablet such. Tablets having the potency of 90.5 to 91.5, we don't have any such tablet. Tablets having potency between 91.5 to 92.5, we have got two such tablets. Next, tablets having potency between 92.5 to 93.5, we have got one such tablet. And tablet having potency between 93.5 to 94.5, we have got 5 such tablets. Okay, I hope you understood this thing. Now we are using the lower limit over here, and these all are the frequency, and if we add on all the frequency, we got 100. That means we have constructed 100 tablets, and these all are the potencies, and these all are the frequency of these potencies. Next we'll have a cumulative frequency. Like cumulative frequency of 90.5 means how many tablets have got potency less than 90.5? Just one. Next, how many tablets have got potency less than 92.5? We'll have 2 plus 1, that is 3, because less than 90.5 means it is obviously less than 90.5 also. Similarly, how many tablets have got potency less than 93.5? The answer is 4. How many tablets have got potency less than 94.5? So we'll have 9, that is 1 plus 2 plus 1 plus 5. So we'll have 9, and so on. And lastly, we should have a figure of 100. So this says about cumulative frequency. We should add on all the things. Now we'll come across another thing, that is cumulative proportion. Means the frequency often expressed as a proportion or percentage also. We can either write cumulative proportion or cumulative percentage. It is the value equal to or less than a given value of potency. It is calculated for each specified value of the potency. Like if you are adding about cumulative proportion, so last should be 1. If you are instead of cumulative proportion, if you want to write cumulative percentage, then instead of 0.01 you should write 1%. Instead of 0.03 you should write 3%. And at last where you can see 1.00, instead of that you can write 100% if you are using cumulative percentage. If you are using cumulative proportion, then you should have a value of 1 as a proportion. Next, after this we can even make a plot of the cumulative proportion versus the tablet potency, and this can be used to determine the proportion of values that lie in some interval, that is between some specified limits. Even the cumulative proportion represents the proportion of values less than or equal to potency. Also, for example, from an inspection of the graph, one can estimate the proportion of the tablets with potency between 100 to 105 mg inclusive equal to approximately 0.48. Okay, so this is the thing regarding the cumulative frequency. Next, lastly, we shall talk about the stem and leaf plot. An expeditious and compact way of summarizing and tabulating large amounts of data by hand, known as the stem and leaf method. So basically, see, first of all we'll have a stem and we'll have a leaf. So what all things are stem and what all are might be the leaf, it can be better or best illustrated with the help of an example. Suppose we have got a raw data. Okay, so first we need to create a stem, and for stem we are using an integer that consists of the first digit of the data, and then we are arranging them in a vertical form. Like first value we have got 11, right? So in 11, what is the first digit, what is the first integer? That is 1. Then 1 will become the stem. Next is 67. Among this, what is the first digit? 6. This is again another stem. Next in 54, what is the first digit? That is 5. 34, what is the first digit? 3. 44, what is the first digit? 4. 87, what is the first digit? 8. 85, again the first digit is 8, we have written. 89, the first digit is 8, again we have mentioned it already in the stem. Next is 98, the first digit is 9. Next 45, we have already written. 43, 4 we have already written. 23, 2 we have added up here. Next 26, 63, 10, and we have got 79. So this will make our stem. Now as you can see, what all digit we have added over in the stem. We have got 1, 2, 3, 4, 5, 6, 7, 8, 9, everything. So better to arrange them in an ascending order like this. Now we'll make leaves out of this. We have constructed the stem. Now we should make the leaves. Now how to make the leaf? We should check in the raw data where in what all values we have got 1 as the first digit. Like we have got 11 over here, we have got 10. So 10 and 11. So the leaf will be constructed using 0 and 1. That is the leaf. Next we should construct the leaf for 2. 23 we have got, 26 we have got. So in the leaf we should write 3 and 6. Similarly we should check out what all values have got 3 as the first digit. So we have got 34, 31. So in the leaf we should write 1 and 4. Next, at what all values we have got 4 as the first digit? We have got 44, 45, 43, right? So here we should write 3, 4, 5. Next, what all values have got 5 as first digit? We have got 54, 52. So we should write 54 is also there. Write 2, 4, 4. What all values have got 6 as the first digit? We have got 67, 63 and 60. So we should write here 0, 3, 7. That implies of 60, 63 and 67. Similarly, what all values have got 7 and 9, 79 we have got. Next for 8 we have got 87, 85, 89 and 80. So here we should write 0, 5, 7 and 9. That implies 80, 85, 87 and 89. Lastly we have got 9, 98, 91, just 2. So 1 and 8, that implies as 91 and 98. So this is how stem and its leaves are being created. The distribution of this data is easily visualized with no further manipulation. However, if necessary, one can easily construct a frequency distribution from the data resulting from the stem and leaf tabulation, and moreover the data are in the form of histogram, which is a common way of graphical displaying the data distribution. Okay, so this is how stem and leaf plot are been constructed, and this was all about this video regarding the frequency distribution, cumulative frequency distribution, and how to construct a stem and leaf plot. I hope you people found this video helpful. Thank you for watching.